Okay, for vector v equals -2, 5, find the magnitude v at an angle between 0 and 360 so that vector v written in written in like, by Lauren, written in like kind of a polar form is like this instead, right? So let's start by finding the magnitude of v. So that would be the square root of -2 squared plus 5 squared. So that would be the square root of 4 plus 25, which is the square root of 29. Oh, that's the same vector we were using on problem 19, wasn't it? And then we want to find the angle this time. So the angle is the inverse tangent of 5 over -2. And it said to go ahead and find our angle from 0 to 360. Don't forget to graph it so that you see it's in quadrant 2. Boy, they keep doing that, where the angle is in quadrant 2, but tangent gives us a quadrant 4 angle, and then we have to add 180 to it. Okay, so let's do inverse tangent of 5 divided by -2, and that gives me an angle of -68.19. I'm just going to start there. I'm just going to call it -68.2 because I started trying to figure out where I wanted to round it, and I'm like, that's good. So, but then I want to add 180 degrees to that because that puts it in quadrant 2. Okay, so add 180. So our angle is 1. Oh, it says 2 decimal places though. Well, guess what? That is 2 decimal places because I got 0.1985, so that rounds the 0.1985 to 0.20. So I am still obeying what was asked. Okay, so 80.80 degrees. So to write this in that form, I would write it as square root of 29 times the cosine of 111.80 degrees, comma, sine of 111.80 degrees. I think what this problem is trying to help you realize is that everything in these last few chapters is all interrelated. Like this would be our CIS stuff if we were doing imaginary numbers, right? But this is an imaginary number, this is a vector. But it's still the same exact process we would use if we were finding polar form. So it's just helping you realize that all of these are interconnected. Now, if we went ahead and multiplied this out and distributed it through, guess what we should get? We should get -2,5 back again. So this is more or less a polar form, but we don't really say we have vectors in polar form. We usually instead say we have like a magnitude and an angle. But there they are, the magnitude and the angle for our vector.